In this video, I'm going to do a couple of homework questions from Lesson 1 and Lesson 1 in radical and rational functions. So I specifically want to look at questions 4 and questions 5 on page 452 and how you would solve these questions. They're on domain and range. Both very good questions to see if students understand this. So what it says is for number 4, the graph of the function y is equal to f of x is shown. State the domain and range of the function y is equal to f of x. So we have a polynomial here, and they want the domain and range of this. So this is a fair question. You could have done this when we did polynomials. So the domain of this function, if I said to you, okay, on this graph, what is the biggest x value? I hope you see that the biggest x value would be 18. Okay, so the domain of this graph would be x is less than or equal to 18. If I said what is the range of this original graph, you're looking for either the biggest or the smallest y value. And in this case, this point here would correspond to the biggest y value, which is 16. So my graph, the range of this graph is y is less than or equal to 16. So that would be the domain and the range of the original graph. Okay, now what we're going to do is it says without sketching. So without sketching the radical graph, determine the domain and range of the radical function. So if you watch the first lesson, we know that in order to get the domain of the radical, you need to look at the graph of the original. So let's maybe make note of that. So look at graph of original. And what we're looking for is where the graph, the y values are greater than or equal to 0. So where the graph of our function is greater than or equal to 0. So from here to here, this piece of my graph, the y values are greater than or equal to 0. Okay, as is this piece of my graph. So from here to here. And again, why do we care about where our graph is greater than 0? The reason is we know that when we're doing our radical graph, we're going to be square rooting y values, and you can't take the square root of a negative y value. So I only care about the positive pieces of my original graph. So these green pieces, if I could state what the domain of this is and what the domain of this is, that will be the domain of my transformed radical graph. So the domain of, I'll do this piece first, I'll just call it number 1. The biggest x value there is 6, and the smallest x value is -4. So the domain of my first my first transformed graph will be x is less than or equal to 6, greater than or equal to -4. Okay, then I need to say or because I have 2 pieces. So now I got to figure out what the domain of this piece is. Now this x value, it's going from 16 to 18, right? So my second piece that's greater than 0 is going from 16 to 18. So if I said, well, what's the domain of that piece? You would say x is less than or equal to less than or equal to 18, greater than or equal to 16. Okay, and the range of my radical graph. So before we do range, we actually have to sort of think about the graph. So let's think about what the radical graph will look like. Okay, so this point here, which is 0, 8, if I said what would that point become on my transform graph, we know that it's going to be the square root of 8. So 0, square root of 8. And I need to figure out what the square root of 8 is. So the square root of 8 is 2.8, so almost 3. So that 0 root 8 is going to go to 0, 2.3. So we're going to have my transformed graph, my radical graph will look like that. Then what I need to do is I know that this is going to be an invariant point. I need to find what that point is going to be on my transform graph. So 18, comma 16 on my transform graph is going to be 18, comma, what's the square root of 16? And it's 4. So that point is going to go to, and it's going to be here. And that point will be at 18, comma 4. Okay, if we were doing the range of this, so now this pink is going to be my radical graph, right? That's going to be my radical graph. And if I said, what's the biggest and smallest y values on that pink graph, I hope you can see that the biggest y value would be 4, and the smallest y value would be 0. So the range on my radical graph would be y is less than or equal to 4, greater than or equal to 0. That would be the range. All right, let's look at number 5. So this will be number 5. The zeros of the function, of the function g, so it says this graph, they're calling it y is equal to g of x. So another polynomial, y is equal to g of x. And it says the zeros are -8, so that guy's at -8, and -3. That 0 is at -3. Okay, the graph of y is equal to g of x is shown. Determine the domain and range of the radical. So let's first do the domain and range of the original, just to get practice. So of the original graph, the domain, the biggest x value, is right here, and it's at 12. And then this is going to go to -infinity. So how you would say the domain is x is less than or equal to 12. That's the domain of the original graph. The range of the original graph, I need to find either my smallest or my biggest y value. Okay, so because this one goes forever, my biggest y value is infinity, and my smallest y value is this point right here, which is -2. So the range of this graph, my graph is going to be y values that are bigger than -2. So how I write that is y is greater than or equal to -2. That's the domain and the range of the original. And maybe we'll just write down the original was y is equal to g of x. All right, let's do our transform graph, which is the radical of g of x. In order to do the domain, we always want to look at the original graph. So go back here, look at the graph of the original function. Where's that graph bigger than 0? Where are the y values of my graph bigger than 0? Okay, so that was -3. This piece here is bigger than 0. So we're going from -3 to 12. And this piece, which was at -8, and it's going to go to infinity, or to -infinity. So these pink pieces are the pieces of my graph that are going to make the domain of my transformed radical. So I need to give the domain of this piece here, and the domain of this first piece is x is less than 12, greater than -3. So the domain of that piece is x is less than or equal to 12, greater than or equal to -3. Or, because I've got two pieces, so I'm going to say or. Now I have to say about this piece here. So if I said, okay, well, how would you write the domain of this piece? It's going from -8, and it's just, imagine that it's going forever, forever, forever. It's going to go to -infinity. So the domain of this piece is x is less than or equal to -8. That would be the domain of my second piece. Okay, we have to get the range. And the range of this graph is slightly more complex. So we know that this is going to be an invariant point, and this is going to be an invariant point. In order to find out where this point goes, the new point is going to be at 12 root 5, right? So 12 root 5 is going to be at 12, 2.2. So the new point will be at 12, 2.2. And this point, 3 comma root 3, is going to be at about 3 and 1.7. So my new graph, it's going to go something like this, to there. So that's going to be the my transformed graph. Now I have to figure out this piece, right? So I know that that's going to be an invariant point, as is the graph at 1. That's going to be an invariant point. And then these points up here, so because this goes to infinity, if I said, well, like, what would this look like? It would be, I'd connect those two invariant points, and then that would just continue forever. So based on this, if I said, well, what is the range of your graph? My range is going to be, so the range of this was greater than 0, less than whatever that value is. But we only need to list one range. So the range of this function here, this piece of my function, is going to be y is greater than or equal to 0, because this is just going to continue forever upwards to infinity. So I would say that the range of the transform function is y is greater than or equal to 0. I'm going to do one last question with you. And the last question I'm going to do is number 9. And number 9, it looks slightly different in your book. So they're giving ranges of functions. In your book, it gives it to you in interval notation. So it says A is from, the range is from -4 to 16. B, the range is from 0 to 16. C, the range is from 0 to 4, square bracket. And D, the range is from -2 to 4. Okay, so what we need in order to do number 9 is we actually need this information here. So it says y is equal to f of x is a continuous function, and it has this domain here and this range here. So if I was to sort of sketch that, so it says the domain goes from -4 to 16, and the range goes from y is -4. So the graph is going to go from there to x to y is 16 as well. Okay, so it says you have a continuous function, and the domain goes from -4 to 16. The range goes from -4 to 16. So then what it's saying for this number 9 is it's saying what would be the range? So we just want the y values. What would be the range on my transformed function when I take the square root of it? So I hope what you see is that this point here, which is 16 comma 16, that new point is going to be at 16 comma 4. So that new point, 16 comma 16, the new point is going to be at 16 comma 4, which will go down to here. And then remember that we can't graph these negative pieces, right, of the original graph. So I can graph this 0, 0. So 0, 0 on the original. What is that going to be on the transformed graph? It's going to be 0, comma 0. So my new transformed radical graph is going to look like this. And this point, so the square root of 16 we said was 4. So the biggest y value is going to be 4. And the smallest y value for the range is going to be 0. So the answer is C.